Welcome back to Guru Tuition Center. If z is equal to x plus iy is a complex number such that modulus of z minus 4i divided by z plus 4i is equal to 1, show that the locus of z is a real axis அப்படின்னு சொல்லிட்டு நம்ம ப்ரூவ் பண்ணோம். சரி, ஓகே. இப்போ இதுக்கு என்ன பண்ணலாம் அப்படின்னு பார்த்தீங்கன்னா, சொல்யூஷனில் z minus 4i divided by z plus 4i is equal to 1. இந்த மாடுலஸை தனித்தனியாக பிரிச்சுக்கலாம். z minus 4i divided by z plus 4i is equal to 1. இங்கே டிவைடில் இருக்கிறது அந்த சைடு போகும்போது என்ன ஆகும் அப்படின்னா மல்டிப்ளிகேஷன், ஒன்றாவோட மல்டிப்ளை பண்ணும்போது சேம் அதே வழி தான். now you have to substitute the value of z is equal to x plus iy அப்படின்னு சொல்லியிருக்காங்க. that means modulus of x plus iy minus 4i is equal to modulus of x plus iy plus 4i. now equating real part and imaginary part. அப்போ y minus 4 is equal to x plus I into y plus 4. modulus cancel பண்ணா என்ன பண்ணலாம், square root on both side. it means square root of real part the whole square plus imaginary part the whole square. y minus 4 the whole square is equal to, அதே மாதிரி இங்கேயும் square root of real part the whole square plus imaginary part the whole square. that means now the squaring on both sides, squaring on both sides. Then the x square plus y minus 4 the whole square is equal to x square plus y plus 4 the whole square. that means x square cancel, y minus 4 the whole square is equal to y plus 4 the whole square. when a minus b the whole square, a plus b the whole square. y square plus 4 square minus 8y is equal to y square plus 4 square plus 8y. now the 4 square cancel, y square cancel, minus 8y இது இந்த சைடு ரைட் ஹேண்ட் சைடு மூவ் பண்ணும்போது அப்போது that means minus 16y is equal to 0. now y is equal to 0. that is z is here, therefore the locus of z is real axis அப்படின்றத எழுதி முடிச்சிட வேண்டியது தான். ஓகே, தேங்க்யூ. நெக்ஸ்ட் செம் பார்க்கலாம். செகண்ட் செம், if that is second one. okay, if z is equal to x plus iy is a complex number such that imaginary part of 2z plus 1 divided by iz plus 1 is equal to 0, then show that the locus of z is a 2x square plus 2y square plus x minus 2y is equal to 0. this value, imaginary part of this value is equal to that one. the locus of z is அப்படின்னு சொல்லிட்டு இது ப்ரூவ் பண்ணும். now we going to prove that. now let us consider z is equal to x plus iy, that you know that. now the value of 2z plus 1 divided by iz plus 1 is equal to, first of all you have to identify the value of 2z plus 1 divided by iz plus 1. that means now 2 times of x plus iy plus 1 is divided by I times of x plus iy plus 1. now we going to prove that it is 2 times of x plus I 2y plus 1 is divided by I times of x, that is I square means it become minus 1, that is plus 1. now equating real part and imaginary part, that is 2x plus 1 into plus I 2y, here 1 minus y plus ix, Now we're going to multiply that. This on a imaginary, taking a conjugate 1 minus y divided by I minus x, divide by 1 minus y minus ix. Because of the rationalize the denominator, because of the denominator we have imaginary part. First of all, you have to cancel that. That means you take the conjugate and multiply it by in both sides, numerator as well as denominator. That means a normal multiplication 2x plus 1 into 1 minus y, next minus I into x into 2x plus 1. 2x plus 1 you have to multiply it by both the terms. Next plus I 2y into 1 minus y. Next plus minus I square into 2xy the whole divided by 1 minus y the whole square, that is minus I square x square. Let's say a plus b, a minus b. Now we are going to prove that is 2x plus 1 into 1 minus y. That's I square is become 2 minus 1, automatically it plus 2xy. That's a real part. Plus I into imaginary part. We're going to write next imaginary part. Imaginary part means minus x into 2x plus 1 plus 2y into 1 minus y. That's imaginary part. Here the 1 minus y the whole square plus x square. That's a value of 2z plus 1 divided by iz plus 1. Now that imaginary part of 2z plus 1 is divided by iz plus 1 is equal to, the question is 0. Imaginary part value of this question is 0. Now what is the imaginary part? This is an imaginary part. That means minus x into 2x plus 1 plus 2y into 1 minus y the whole divided by 1 minus y the whole square plus x square is equal to 0. Okay. Now this one denominator we can move this side, means it become to 0. That is 2x square minus x plus 2y minus 2y square is equal to 0. Now rearranging order in multiplied by minus 1 on both sides. That means 2x square plus 2y square plus x minus 2y is equal to 0. Answer proof. Okay. Now the third sum. Obtain the Cartesian form of the locus of z is equal to x plus iy in each of the following cases. Now real part of iz the whole square is equal to 3. Already we know that the value of z is equal to x plus iy. That's a given value. Given. Am I correct? Now iz, that means I times of x plus iy. Now ix minus I into I square value is become to minus y. That's a minus y plus ix. That's the value of iz. Now real part of iz, that means real part of iz means y minus y. Now the real part of iz the whole square, that is mean equal to 3. that means minus y the whole square is equal to 3. That means y square minus 3 is equal to 0. This is a locus of z. We are going to prove that second sum. What is the second sum? Means imaginary part of 1 minus I into z plus 1. Imaginary part of 1 minus I into z plus 1 is equal to 0. Now we are going to prove that now 1 minus I into z plus 1 is equal to 1 minus I into, what is the value of z? X plus iy plus 1. Now we are going to multiply it the same manner, x plus iy. Now minus ix, I square value become plus minus 1, it become plus y, it's a plus 1. Now equating real part as well as imaginary part, y minus x. Now that's a imaginary part of, that's a value of 1 minus I to z plus 1 is equal to this. Imaginary of 1 minus I into z plus 1 is equal to 0. That means imaginary part means y minus x is equal to 0. That's a locus of z for the given questions. Now third question. Third one means, what's the value of third one? Z plus I, modulus of z plus I is equal to modulus of z minus 1. Now we are going to substitute the value of x plus iy plus I is equal to x plus iy minus 1. Now equating real part and imaginary part, y plus 1 is equal to x minus 1 plus iy. Now we are going to cancel the modulus. Modulus means square root on both sides. That means square root of real part the whole square plus imaginary part y plus 1 the whole square is equal to, as well as square root of x minus 1 the whole square plus imaginary part means y square. Okay, now the squaring on both sides. Squaring on both sides. Now squaring on both sides means x square plus y plus 1 the whole square is equal to x minus 1 the whole square plus y square. Now expand the values, x square plus y square plus 1 plus 2y, that is a plus b the whole square formula. Here a minus b the whole square, x square plus 1 minus 2x plus y square. Now y square cancel, x square cancel, plus 1 cancel. Here plus 2x plus 2y equal to 0. That is means x plus y is equal to 0. This is a required locus of z. Now we are going to prove that the last one, fourth one. Z bar is equal to z inverse. Solutions. Z is equal to x plus iy. That means z bar is equal to z inverse. That means x minus iy is equal to 1 divided by x plus iy. Now you have to cross multiplications means x minus iy into x plus iy is equal to 1. That means x square plus y square is equal to 1. A plus b into a minus b means a square minus b square. I square values become to minus 1, automatically we will get plus 1. Ends up.